Welcome to a Monday morning class. Let's see, I'm gonna try to see if we can get through the homework. Let's see how we're doing on it here. And then we'll either do something else and as we prep for the class, for the test here. So let's jam. Let me change my screen mode to screen number 1. All right, you guys had it there. And let me get this set up here. So you guys, please take out any homework questions you guys have. Let's do those first. I do want to tackle those. Hopefully we can get through all of them that you have trouble on. And I want to make a new screen.
Didn't you share screen? There we go. Hang on. No, it's up there. Hold on.
All right, let's go with it here. And let me take
I shouldn't be the one doing this. I'm just
on the next screen. All right, are we good there?
Guys,
Isabel, we're doing good there?
I can't see anything through Vix.
Say that again.
You can't see your screen share, but Landon is trying to fix it. We can see your computer screen. There we go. Look, Landon fixed it.
Let me get rid of my video. Okay, let me stop the video because that will help with the bandwidth on the video on the screen share. Okay, talk to me now. Is that better?
Yeah, Landon fixed it.
Awesome.
I think we're good.
Okay, let me see. My computer is acting up just a bit as well here. So let me go to, okay. Huh. 1 second, just trying to make the my second screen video larger of you guys here so I can see you. Oh yeah, there it is, perfect. I can see you guys on the other screen. Okay, let's jam here. So let me get this right here in front of me. All right, and all right. Let's go to let me do 1.3 just in case we have questions from 1.3. So we got 1.3, 1.4, and 1.5. Let's see how much of those we can handle right now so you guys are at least have more confidence in where we're at. So if you have any questions, let's do this. You just say which section it's coming from and then the number. So let's say like 1.3, 21 or 1.4, 17 or something. Let's do that. Dylan, go ahead.
Well, this is more like a broad question. It's a lot of questions. Like I understand how to do it, but I don't understand why or like how we find the domain in I think 1.4.
Okay, give me a problem. So for domain, let's do this here. I can work through the homework question itself, and I can do it off the side here. So just the domain question, right?
The like section where we have to find the domain.
Okay, we'll get to that one. Absolutely, Dylan. Thank you so much for asking. Concept questions, please do it. That's very important part of understanding the math behind things. Absolutely. Cool. Okay, next, so you guys look at your homework sheet, look what you guys did. Which ones did you guys get stuck on? And give me that list there. We'll try to go over those.
This is from 1.2, because I forgot to ask it earlier because I didn't have the homework with me. But I don't understand how to check for symmetry.
symmetry. You got it here. Abe, do you know which problem in particular that was? I think it's 27 or 31, one of those. I'm gonna go with 31 on that. Is that okay?
Yeah, it was like 27 and 31.
Okay, perfect. Yeah. Awesome. Thank you, Abe. Any others? Guys, go for it. Let's get a list going here and then we'll go through it together here. So give me a list. Charlie?
1.437 A, B, C.
ABC. Absolutely. Okay, good. Thank you. All right, anybody else? Go for it. One's going twice. Is that it? I think that may be it. Is that it? Okay, so let's go for it. 1.2, number 31, the symmetry problem here. So testing for symmetry, here it is. And let me show you the different pieces here. And so, and I'm gonna do kind of like mini lessons on this stuff here because I do want you guys to understand the concepts here. So we want to know if it's symmetric about the y-axis. So y-axis is right here. And so if you notice, if you're to put x and y, put a little dot on this side of the y-axis, put a dot on this side of the y-axis, the only change that you see is the negative x. So what we do, we have to test for actually three different symmetries here. So when we test for x-axis symmetry, y-axis symmetry, sorry. What we do is we plug in a negative x comma y, and we want to see whether it's just going to turn out to be the same equation as a positive x positive y. So basically it's saying there's no difference between plugging in a negative or a positive. They're going to hit at the same spot, or it makes the same exact equation. A good example would be something like this. F of x is equal to x squared. X squared is a pretty good example because notice it's symmetric about the y-axis. So if you plug in a negative x, it still gives you the same value as plugging in a positive x. It still gives you the same y. So y-axis symmetry, here it is. You plug a negative for the x. And you're testing for two things here. You're testing to see if you get back to the exact original equation you had, or you have the exact opposite equation you have. That's kind of what you're doing. You're testing for it. And so in this case, this drops out and you're left with something that looks like this. So back to the original one, you're looking for this and you're looking for this. And you're saying, okay, does that look like the exact same equation or the exact opposite equation that I had? No, neither of those. So there's no x-axis symmetry here. Okay, let me just check something out real quickly here.
How would it ever look the same if you're changing something?
Yeah. So 1 second here. Maybe best to let me check something out just real quickly here. Let me set this guy equal to y. If we solve it for y, do we get something that looks like this? Is that right? Should have started with an easier example here. 1 second. Give me 1 second, class. Let me check out something. Okay, Abe. Not to steer you in the wrong direction. X-axis symmetry. It does say x-axis symmetry. for it. Just 1 second here. Abe, real quickly here. Yeah, I was just kind of making sure that we didn't have to solve for this one here. So notice it doesn't come back to the original problem here because you get this little extra negative sticking out for the x. So there's no y-axis symmetry here because plugging in a negative x doesn't get you back to the original problem. Let's look at y-axis symmetry because that'll be the easier one to sort of see. And so let me go into the next slide here. So I have this right here. Y-axis symmetry, I'm sorry, x-axis symmetry is going to be this little line right here. So it's a dot here, x comma y, and this one's going to be a x negative y. So notice there's this little connection right here. So plugging in a negative y wouldn't change anything as plugging in a positive y. And so to test for, I'm getting x axis symmetry. Again, just testing for it. We're going to plug in a negative y. Keep the x the same. And we're going to see if it just gives you the exact same thing as a positive x, positive y. So plug in this in here. I'm going to put that in there. And that's what, and usually happens when you have that x squared or y squared in there. That's going to make everything disappear. The negatives go away. And you're left with back to the original problem as you had before. So I don't know what this graph looks like, but I know it does have y-axis symmetry. Abe, are we okay with that one?
Yeah.
Okay, then we have one more because you have to test for all three. Next one is symmetry about the origin. Symmetry about the origin means if you have something here or down here. So negative x, negative y would give you the same thing as a positive x, positive y. Maybe a good example would be x cubed. That's a good, it goes like this. That has symmetry about the origin. So in this case, we're plugging in both as negatives. I plug in negative x and I plug in negative y. Question is, do I get back to my original problem exactly the way it was before? And the answer is no, because that little negative x in front there. So this one's a no. All right, Abe, was that good? It makes sense there?
Yeah.
Awesome. Okay. That's 1.2, 1.4, 37 for Charlie, A, B, and C. And then Dylan, just want to talk about domain just for a little bit here. So 1.4, jamming to 1.4. Got 37 on my hands. Okay, I have a function. It's called a piecewise function. So we use different parts depending on which x value we're using or where we're at. So this guy has 3 different parts to it. So along the x-axis, if we are less than -1, or this side, we're going to use the top function. Between -1 and +1, we're going to use the middle function. And anything above 1, we're going to use the x squared function. And so just to kind of give you a little bit of an idea what that looks like here. Remember, this is a linear function, mx plus b. So it seems like it's going to go like this. It's going to go, this function goes up to here. Here's your 3x, not a perfect graph here. But this will be your 3x minus 1 graph, and it stops right there. And then 1, 2, 3, 4. Anything between -1 and +1, we're at +4, just a straight line, horizontal line straight across. And then anything at x squared, with 1 being there, it's going to go like this. So I want to give you guys a visual, at least what a graph looks like. That's what the graph looks like right there. Now, we don't need to know what the graph looks like as far as doing our problems here. So our problem for A is, can you find for me f of -2? And so we have to search here, say which function I'm going to use if I'm looking for f -2. Top, middle, or bottom? And the top, that's the function I'm going to use. I'm going to use this guy here, 3. Let me write it like this here, 3 times -2 minus 1, because we're here right now. We're at -2. And so we're going to use that bottom function there, or the 3x minus 1. Cool. That's going to be -6. And how about a -7? Are we good there? We go on to B. B says, can you find me f of -1/2? All right, which function am I using now? The second one, the middle function, it's this guy here. So I need the x to be between -1 and +1. This one's easy. This one's a constant. It doesn't change with x. The answer is just 4. That's it. It's this middle function. We're about right here. Here's our, oh no, we're about right here. Here's our -1/2. And we're just using that function there. For C, I need f of 3. So notice again, going along these little lines here, that's the one I'm going to use. X is greater than 1. Therefore, the function is the square function. Answer is 9. So piecewise functions, they're cut into pieces to be used at different spots, different ways. Maybe like, where have I seen this done before? Cell phone bills, especially like data usage bills. That's where it's usually used before. So up to maybe 5 gigabytes, you have a flat fee on your hands, right? The cell phone company says, I'm going to charge you this much. And then after the 5 megabytes, I'm going to charge you per gigabyte used. So notice one part is flat, and then afterwards, then it changes into a totally different function beyond that. I think mail. Let's see, if you send out a package works the same way. Let's say you go to the post office and you want to mail out a package. That's what they use as well. So let's say from 0 to, I think it's by ounces. I think it's like 8 ounces of weight. It's this function. And then if it's anything above that, then it's this one. So you pay more. And then after that, it's almost like it's per ounce. Then you're paying per ounce for each one. So there's 3 different functions there that they use. So up to the first 16 ounces, I should bring this down. Then from there, then use that. Okay, are we good there? Piecewise functions. Charlie, does that make sense now?
Yeah.
Okay, so let's go on and let's talk about domain.
I also have another question that's not really related.
Sure, Dylan, what is it?
On the test on Wednesday, are the formulas, like the distance formula, the midpoint formula, are those going to be on the board, or should we have those memorized?
Thank you so much. Okay, when you guys come in to take the test, yeah, I'll have to print them out. I'm gonna print them out. It'll just be an extra sheet that you guys will have. So you guys talk to me here. I'm thinking the factoring formula, all those factoring formulas we have, the distance formula, midpoint formula. Any other formulas you guys can think of?
The circle formula.
Circle formula. Perfect. So factoring, midpoint formula, distance formula, and the circle formulas. I think those are the major ones that we had. All right, any others going once, going twice that you guys can think of?
The difference, like the slope formula and equation of line.
Thank you. Slope formula, slope intercept form.
And the point of a slope as well. The point slope form.
And the point slope form, right? That one. All right. Anybody think of any others? Going once, going twice. No. Okay. Perfect. Okay. I'll make sure we have those on a sheet. All right. Let's talk about domain. Domain is important in real life applications to say this function only works at a certain point. It does not work any other point. So let me go back to the cell phone problem. Cell phone problem, it says from 0 to 5 gigabytes. I'm just randomly using that. And so notice you don't get a cell phone bill in the negatives. That doesn't make sense. And then up to a certain amount, you get this, and then afterwards, it's a different phone bill here, right? So domain is important, first of all, in restricting what we're going to look at. So in this case, whatever this cell phone bill looks like, I'm going to say, look, I'm going to say that x has to be greater than or equal to 0. So that restricts this domain to say, look, I'm not even thinking about the negatives here for this particular problem. All right, so in a conceptual way, domain restricts what we're looking at because this function only works for this. Another one that's maybe a good one to sort of think about is maybe like growth rate of boys and girls, right? You have a model that says children are going to grow in about this chart right here. Here's kind of your chart, and this chart stops at 9 years of age. So don't use this chart after 9 years of age. It's not going to work for you. This chart is really made for from 0 to 8 years of age. And so it kind of restricts what you're thinking, what the graph is used for, what the chart is used for. In a math way, we have domain on problems themselves. So this is now kind of like the domain in mathematics here. And so with functions, maybe even easier, like this, something like this, 3x plus 2. That one, that one's going to have a domain from negative infinity to positive infinity, which means I can plug in whatever x I want into this. There's no restriction on my x's, just based upon the function alone. All right, the other one is this one right here. There's another one, polynomial functions. Okay, this one also is going to be from negative infinity to positive infinity, because there is no restriction based upon x squared plus 5x plus 6. There's no restriction of what numbers I can or cannot use to plug in. So everything gets plugged in. The problem in mathematics comes in 2 different ways. One is called factoring. Oh, sorry. One is called fractions. There you go, not factoring. Fractions is one problem, and square roots is the other. So fractions are a problem because when I put this together, you guys talk to me. Is there a problem that if I were to plug in, it would make this undefined?
-2.
-2. Absolutely, right there. So in this case, you can kind of write it two different ways. You can say, look, all the numbers work from -infinity up to -2. Then there's a break at -2, and they go on to positive infinity. That's kind of one way of writing it. Another way to write it is you just say all real numbers except x equals -2. There you go. So you're saying, hey, look, all these numbers work just fine because it's a fraction, except that -2 is going to cause our problem. Square roots are the other one here. So now this one right here, square root is, let's say it was x plus 3 inside here. So talk to me. We learned from Algebra 1, what number can you not take a square root of? Because you can't take negative numbers, absolutely. So in this case, we got to think about, okay, what would make this to be a negative number? And always say, but we're going to restrict it to our domain. So we say x plus 3 works as long as that x plus 3 is greater than or equal to 0. And so if we subtract 3 from both sides, I get this right here. My answer is that all the x's work as long as the x's are going to be greater than or equal to -3. How do we show that? I would go negative bracket this time, right? Because bracket means I'm including the -3. -3 all the way up to positive infinity. So that's called interval notation right there. And then some textbooks, they do prefer this one as well. You just kind of write down, I need all the x's that are greater than or equal to -3 work. So that's a good answer. That's a good answer. All right, Dylan, does that help out in the understanding of things with domain?
Yeah, but for square roots, like in the homework, there was square roots like that to the 4th power, to the 3rd power. Is that just the same exact concept?
Oh, perfect. Okay, let's talk. I usually say square roots, but yeah, we should define it more here. So for cube roots, let's go cube roots. Let's keep on going for a little bit here. You guys talk to me here. Let's talk about this here. If I have a cube root of a, let's do 8. That's fine. Give me a number, multiply itself 3 times to give me 8.
2.
2. All right. Give me a number, multiply 3 times to give me a -8.
-2.
-2. Notice a positive 2 and -2. Notice the negatives are able to be worked into a cube root because you have 3 of them, right? And because you have 3 of them, you can make it either be a negative or a positive here. So how about a 4th root? If I do this here, 4th root of, and let's see, 3, well, let's go with 81. 81 should be in there. So I need a 4th root of 81. A number multiplied itself 4 times to give you 81.
Three.
3 is good. I'm waiting for PowerPoint to catch up here. There it is. And I heard 3. Perfect. And then how about this one?
That doesn't work.
Thank you so much, Isabel. Yep, does not work. Okay, so let's do the major thing here. So it's not so much as square roots, it is very much even roots. That's our problem. Even roots, we have a domain problem. For odd roots, there is no domain problem. Okay, Dylan, does that help out? Does that make sense?
Yeah, so how would you answer that though? Like what would the answer for those be?
For which one?
Both of them. Like, would it just be -2 and then all of those?
Oh, for this one right here, you would say not a real root. So not a real root. And then, but the domain problems are going to happen more like this. They're going to say, what's the domain for f of x is equal to 4th root of 10 minus x? That would be a fun one. What's the domain here? And we're going to do exactly what we did for the square root. We're going to say, okay, when does x minus 10 minus x going to be greater than or equal to 0? Solve that one. In this case, I would subtract 10 from both sides. Get negative x greater than or equal to negative 10. Divide through by negative 1. So this guy will have to flip on us. And I got this right here. X. So the domain for that particular function is x less than or equal to 10, or it works from negative infinity up to 10, but no more. Okay, are we good there with that? All right. Let's go with any other homework questions, anything that you guys are still dealing with, going through. If not, all right, talk to me. Honesty question here. You guys should be able to finish up 1.5 and be ready for a test Wednesday. Is that a good feel of the class?
Yes.
Isabel, go ahead. You gotta, yes? Okay, cool. Okay. Let's do this here then. I'm going to change gears. We are going to quickly go into a fun little thing I made. Let's see how big of a hit this is. So I'm going to jump to this. I'm going to bring this down. We're on screen 1. Can we do screen 1? I'm just kind of thinking about it here now. Let's see. No, I should do screen 2. My mouse is acting really, really funny here. So, or my tablet here. Let's see if I can get to it. Nope. Let me change my screen here. Screen share, change. All right, you guys tell me, what do you guys see?
One slide. Oh.
Okay. Let's see if I get this thing started here. One slide, yep, that should be the one slide. Let me get this to go like this. Do you guys see like something about Jeopardy template or something?
Yes.
Awesome. Okay, I'm going to put you guys on the side over here so I can see you guys. All right. I think I have even music to this here. Let's see. We're going to go with it. We're going to play a little Jeopardy game. And we have 4 teams are set up just perfectly here. So Isabel and Stella, guess what? You are team 1. Landon and Dylan, team 2. Annette, Charlie, team 3. And Abe, 4.
Okay.
I got the choice.
Hey, Charlie, you want to switch spots?
So just the way you're sitting, consequences and where you sit. Okay, Abe, the only thing is, Abe, I can barely see. I can see like your, sometimes I could see your left hand. So let's see, you're gonna have to at least scoot back just a little bit here, or you're gonna have to shout out, you know, the answer or something like that. We're good?
I'll just yell the answer.
Okay, so just like Jeopardy, you guys have to tell me when you are good to go. But here's our categories. Our categories are. Oh yeah, I got music here too. Awesome. So we have rectangular coordinates, graphs and equations, linear equations, functions, and analyzing graphs. Technically, it's 1.1, 1.2, 1.3, 1.4, 1.5. And I know it goes up to 500, but I only made it up to 300. So we're gonna go up to 300 and we play this. Okay, we good? I'm gonna start off first, and then whoever gets it. I'm gonna go rectangular coordinates for 100. All yours, go. Tell me.
Got it.
3.
Hold on. Too fast.
Got it answered in the form of a question. He's
Quadrant
wrong.
3. Quadrant 3.
What is quadrant 3?
Hold on, we're gonna go with this. Since I see your faces, you have to raise your hand. I'm gonna pick on who went first. And so I'm gonna go with Isabel, because Isabel raised your hand first.
What is quadrant
You
3?
ask the question.
What is quadrant 3? True. Is it 3? Yes, it is 3. Okay, I got a sheet of paper. I gotta get a sheet of paper to keep roll here of things. Okay, team 1. Team 1 gets 1 point here.
What?
Packing up your backpack.
1, 2, 3, 4. Okay, Stella and Isabel, let's go with, see, I messed up. I can't believe that I messed up. It's supposed to be 3. You guys get to pick. All yours, go.
Oh, we have to pick. Oh, okay.
Stella's using your
Cheater.
Cheater.
Negative points.
Cheater.
So does Isabel.
What's going on?
The whole team is great.
Yeah.
Disqualified.
I was looking at it.
Choose a thingy.
Okay.
It only does something.
Rectangular coordinates for 200.
All right, here we go. And the answer is, I'm looking for hands being raised, right? Oh, a distance equation. Oh man, no fun. And I want the exact value. So I need the exact value of the distance. And so raise your hand when you are ready.
What's the
Yeah, that's the problem. I don't remember the distance
Don't
formula.
worry about it.
Oh, no.
Dylan!
Hey, someone go look at Dylan's paper.
Stay away.
I can't read. So good.
switch back, Dylan?
Okay. Hey, if you get the answer, you have to reach your left hand across the screen. We good?
Okay.
Only your left hand. If you do it with your right hand, you're fine.
Dylan, I got an answer. Dylan, go. And
Hold on, are you working through it right
I'm
now?
working through it.
Hold on, we're gonna take a small break.
Okay.
Just gotta check it between the two of us.
Yeah.
Well, you already raised your hand, so answer. You got 10 seconds.
Just go ahead and disqualify and get negative. You
Yeah.
have to answer.
Is this a rule?
5,
Yes.
4.
I have
I
7.
think you got an answer.
I don't think I did it right, but I have 7.
I'm gonna be pissed.
Why?
Because I said we should just answer 7 for all of our questions.
Dylan, all yours, man. You have to answer the question.
I said I have 7.
Say that again.
7.
7? I don't think so.
Points, negative points. What's the formula? Does everybody
It's
know?
x2 minus x1 plus y2 minus y1.
That sounds way too hard and way too
That's-
complex.
Oh wait, is the answer 8?
The answer is not 8.
That's 5.
I'm working through this again.
I didn't check my math and I kind of just went for it.
Is it 3 over 5? Wait,
No.
no.
Is it by any chance the square root of 29?
Oh gosh.
I don't think you're 24.
Is it root 34?
Root 34. A,
What the heck?
We're so
What
good.
is that?
You people didn't even do that.
I did.
What did I do?
Not really.
Couldn't just guess. I did the math.
Wait, how'd you get that?
It's like the squared root thing with the squares.
Yeah, I did it backward. I forgot to square and then square.
I did it the right way, I was just way too slow.
Yeah.
Yeah, we got $200.
We
So do we want to take this cash or credit?
Let me all.
What? We're not getting money?
No.
Then what's the point of playing this?
I would get 200.
let me go to this.
No, we're a team. We're splitting this.
I'll give you
70-30.
10.
Let's do this. Distance formula. This formula is, oh, come on.
B equals B
C
squared equals
Oh,
square root x2 minus x1 squared.
it's just radical of x2 minus x1 squared.
Yeah, no,
No,
this
plus.
is
X
Plus.
minus X1
Plus
squared,
Y2
plus
minus
Y2
Y1
minus Y1 squared. Yeah.
yeah. See,
Literally
B
on the
equals
board.
Oh, I thought you said
Hold
like
on.
a quadratic.
no.
And D.
I'm just gonna eat my strawberry.
Oh, it's gonna get some cold.
I probably damaged the team more if I actually tried to answer.
True.
I think it's like, is that right?
Oh, and
Yep.
Dude, we need Owen. He makes this so much more fun. No force either.
It's-
Sometimes take it way off.
See?
Let's see, plus, and what is that, 3 squared, right? So it was 25. My mouse is not being funny with me here. Plus 9, there's your, come on. There's your 34, are we good? Which, Abe, you did that in your head, is that what you did?
half no paper.
I kind of like having it on my email.
He doesn't like having you on his team.
It's a parasitic relationship.
Yes.
That's not reciprocal.
No.
Okay, back to the board here. Let's see if I can get back to the screen that I want. We go to here.
If Owen was on our team, you'd split it 50-50 with him.
Yeah.
You gave 0, so choose your next category.
If you answer a question, I'll play it.
No, that's my money then.
Whoa, sorry. That was the first one here. Let's go to where we are. Okay. Abe and Camille, all yours. Which one would you like to go with?
Why? That seems so hard.
You said functions for 300.
Functions for 300?
We're ready.
Hopeful.
Yeah, no, we're not.
You killed us all.
Get ready.
Ah.
Oh.
Oh, wait, what?
That did not go as planned.
Can we just do functions for 200?
No. We have $500 now.
It's true. So 250.
Daily double.
Sorry, not playing daily doubles today, but go ahead.
Answer. Daily double.
Yeah.
Answer. Daily double.
All right, raise your hand and when you guys are done. So we have g of x is negative x squared plus 4x plus
Daily
1.
double.
Trying to find g of x plus 2.
Answer.
Shut up, I'm trying to work.
Abe, are you doing this mentally?
Answer. Daily double. Answer. Daily double. Answer. Daily double.
Dylan,
Answer. Daily double.
gotta speak loudly though.
Look, I have x squared plus 8x plus 13,
Daily double.
which I did not factor. Well, hold on.
Do this because
Answer. Daily double.
Negative points. Negative points.
Yeah, just ignore my answer.
No, that's what I had. Why did you give the answer?
Yeah,
Dylan, that's not what you had. Abe, is that what you had?
Yes, I had negative x squared plus 5.
Annette, can you look at his sheet of paper to make sure he had it?
Me? Oh, no, I have it on my head. I don't have the paper.
He doesn't have
He has
papers.
his head. He has his head login.
In his head. Should we give it to him?
No points.
No, yeah.
No points, no points. Da-da-da-da.
Oh.
I'm gonna go with Camille and Abe. Go for it. Choose.
Don't mess up.
I want a 500 question.
Camille, there
It
are
only
no.
goes up to 300.
Can we pick Final Jeopardy?
No.
Oh.
Now the game.
Do you want to kill us all, Camille?
I want. Which one's gonna be the non-hard?
Linear equation.
That's what I was gonna do. I want linear equations for 300.
That's harder than
All right, I think we're gonna finish up with this. Go. As long as it goes. This is pretty loud here, so you guys have to talk loudly over the music here. So find the slope of the line passing through 3, 4, and 3, 1. Landon, talk loudly.
3/1.
No, not 3/1.
X equals 3. Oh.
So it's the slope of the lines. Abe. Abe. Answer?
Is it just x equals 3?
No. Isabel.
Undefined slope.
Undefined slope. It is.
It's vertical. It's a vertical line. It's an
X
undefined
equals 3.
slope.
That's a vertical line, which means it's undefined slope.
Actually, the formula is y equals 3.
So the formula should be y2 minus y1 divided by x2 minus x1. And what happens here?
That's horizontal.
I that.
No slope or
It's undefined slope.
Yeah, but you have
And so it would have been a 1 minus 4 on top, or a negative 3 on top. But then it would have been a 3 minus 3 on the bottom, which is 0. So it would have been negative 3 over 0, which should have been undefined at that point. 300 added to that end. Let's see, I think we're at time. Is it 9:25?
Yeah.
Okay, let's stop there. A team 1 wins.
No, they don't.
Oh, bummer. Okay, real quick here, Isabel, I was wondering if you can someone spray down the chairs, or desks and chairs, please? I can do that.
No, like we're completing our wins. Like, you know what? Whatever.
All right, bye you all. See ya. Isabel, thank you so much.